Okay, this is from the mock exam, free response number 5. So part A, you need to write but do not evaluate. That just means set up the integral to get the area of R, okay? So the area of R is going to be the integral of the top, which is the e to the x. That's, let me get another color. That's this one. That's e to the x up here. Okay, so the top minus the bottom as it goes from the smallest x value is here, that's 0, and the biggest x value is right here, is pi over 2. And that was equal to 1 point. We do not have to solve it, it just says to set it up. Okay, for part B, we want to find the volume. So when I hear volume, I am thinking pi in integral of the top squared minus the bottom squared dx. And I can always adjust that, but this will give me an idea of what I'm doing. Okay, so we want to revolve about the x-axis, so that means it's going down this way. So this is good because it will be the top minus the bottom. So I'm going to take this out, and my top function is the e to the x, and my bottom function is the cosine x. Okay, and my smallest x value is 0, and my biggest x value once again is pi over 2. And if you just did this setup, that was equal, okay, actually all they wanted to see was that you had two functions and that you were subtracting them. So you got 1 point just for showing that you're subtracting them, that it's the top minus bottom. Okay, so this is no calculator, so we have to do this by hand. So let's simplify. So e to the x squared, so the exponent to this x is a 1, and there's a rule that says if you have an exponent to an exponent, you multiply them. So this is going to give us an e to the 2x minus, when you square a square root, you just get what's left inside, so we get that. Okay, I'm going to erase this because we're going to need a bunch of room to work out the antiderivative. So we have pi. Okay, the antiderivative of e to the 2x, so we're going to get, we know it's definitely e to the 2x. But now let's check ourselves. So if I take the derivative of e to the 2x, I get e to the 2x, so it does match. But it would also be times 2, and there's no 2 here. There's nothing there. It's blank space. I don't want that to look like a 0, but it's a blank space here. There. So in order, we have an extra 2, how do we get rid of an extra 2? We have to divide by 2, or multiply by 1/2. Okay? Minus, the antiderivative of cosine x is sine x, and I'm going to check the derivative of sine x is cosine x, so it works. And that is going from 0 to pi over 2. Okay, I'm going to make some room here. And I know people are still going to have questions about my antiderivative, so I just want to go over that. So if I check this, I would take the derivative of that, I'm going to get 1/2. E to that anything is e to that thing times the derivative of the thing. The 1/2 and the 2 cancel out, and you're just left with e to the 2x, which is what we started with, so it does match. Okay, so now we just have to put our values in. So we have pi. So first we're going to put pi over 2 in there. Okay, so that's what happens when we put pi over 2 in there. And now we're going to put 0 in there. Okay, now we just have to work out this algebra. So we get 1/2 e. These two's cancel, so we just have a pi. Okay, what is sine of pi over 2? So let's look at our unit circle. So pi over 2 is located right here. That is the point 0, 1. And it goes cosine sine. So I'm going to just carry down the subtraction sign, and sine of pi over 2 is right here. It's equal to 1. Okay, that's our first piece. Minus 1/2. E to the 0 is just 1. Anything to the 0 power is 1, so it's just 1/2. Minus sine of 0. So sine of 0, 0 is located over here. That's the point 1, 0. Cosine sine. So sine of 0 is equal to 0. Okay, we're going to keep simplifying. So we have 1/2 e to the pi minus 1 minus 1/2, because I'm distributing this negative sign out. And then nothing's going to happen with the 0. And let me make some room. You could have just left it like that, but if you wanted to just clean it up a little bit, 1/2 e to the pi. A negative 1 and a negative 1/2 is a negative 3/2. Okay, so, let me give you your point values. Sorry, I totally forgot to do that as I was doing it. Okay, so at the beginning I had said if you just had that subtraction sign, that was equal to 1 point. If you got the antiderivative of this, to get you this answer was worth 1 point. If you got the antiderivative of the cosine x, so if you just wrote sine x, that also got you a point. And then your final answer, that was worth a point. So that whole part B, that was worth 4 points. Okay, and the last part is part C. And we're talking about cross sections, so immediately I'm thinking of an integral of the area of the cross section. And it's perpendicular to the x-axis, so therefore it's going to be a dx here, and I'm going to use x limits here. And they are going to be semicircles. Okay, so the area of a semicircle is going to be pi r squared, right? That's for a whole circle. A semicircle is half of it. Okay, and I'm just going to put in our limits here, which we already knew from before. And this is another one we just have to set up. We don't actually have to solve. Okay, so it's saying that it's going to be semicircles. All right, so let me get another color. All right, so if I need to be perpendicular to the x-axis, just consider I'm taking slices like this, right? So each of those slices is going to be considered a diameter. And so what is the length of each of these orange pieces? So each of these orange pieces is going to be just, I need another color. It's just going to be this top minus the bottom. That's all. So let me go back to my black color. All right, so our area is going to be pi. The r is the top minus the bottom. So it's pi r squared over 2. And so now we're just going to plug that into here. When you do that, your final response will be this. Alright, so let me let you know what the point values were. If you just got these limits, if you just did this, if you just set up an integral going from 0 to pi over 2, that was worth 1 point. If you got this middle piece, that was worth 1 point. And then if you put the whole thing together, that was worth 1 point. And just in case you're wondering, yes, you could have pulled the pi over 2 out to the front of the integral, and you would have gotten credit for that as well. Okay, so that's it for that one, and that one only took 10 minutes, so that was some good timing.